It was interesting. If you look at a smartphone is nothing more than a sensor suite with onboard compute. So we think we're at that same junction now in Earth observation because a satellite is basically a box with a bunch of sensors.
That's not just a clever analogy, it's a vision of how Earth observation is about to change. My guest today, Michael Bartholomeusz, has lived this transformation firsthand. From the space shuttle program that launched John Glenn to the building of next generation satellites at NOVI. But we aren't just reflecting on the past, it's challenging the way we think about Earth observation today and pointing out why the current model is broken.
But the rub is that comes at an extremely high cost. When you transmit all of that raw data down to Earth, which has to be stored and curated, and only a small fraction of it is used, that results in a very fragile economic case.
And this gets to the crux of the issue. Too much data, too few insights, and a cost structure that locks out most of the world. Which is why the timing for edge computing in space is so critical.
We've arrived at that junction where you now have the viability to push processing to the edge.
When you do that, the economics flip overnight.
Imagine a hedge fund or a logistics firm wants to count ships in Baltimore Harbor. You're probably looking at a price tag of somewhere between $120,000 to $150,000. With NOVI's solution, you can do that for under $1,000.
We talk about a shift that could take Earth observation from being out of reach to many to something accessible for everyday industries and innovators around the world. Future is spatial, so let's get into it. All right, Michael, welcome. I'm excited to have you here. I mean, the first time we talked, we got to learn a little bit about, kind of your take on Earth observation. And I think some of the ways that, we can definitely modernize and change our approaches to really just handling and processing data way more efficiently. But I'm going to let you kind of tell that story. But as we kick it off, can you give me a quick intro into who you are and what you do and how we find ourselves here today talking about Earth observation?
Certainly. It's a pleasure to be here, Matt. Thank you for having me. I've had a 25-year career that spanned multiple industries. My trade craft has mainly been around enterprise development and growth and commercializing technologies. I did start out in the space industry. I actually worked on the space shuttle program that launched Senator John Glenn into space the second time around. And I joined NOVI last year and really joined this team to prosecute a dual-use strategy. NOVI, as we talked about, Matt, has been firmly ensconced in sort of the DoD vertical, but now we are migrating into dual-use and commercial endeavors, and that's what I was retained to do. But I've known NOVI and the founders since 2008, so it's an absolute privilege to be a part of this team.
Yeah. One question I do have you been to a space launch before? Because I'm very jealous of those who have been to one.
Yes, when we launched assets into space earlier this year, I went to Vandenberg and saw a satellite go up on one of the transporters. It was an incredible experience. It was a really incredible experience.
That's a bucket list item for me, for sure.
Definitely worth it, Matt. And SpaceX does a heck of a job curating the whole event. It was something else.
Yeah, very cool. So let's dive in, because I think one key thing that when we had our first conversation was kind of talking about the ways we're collecting Earth observation data today. There's a lot of kind of inefficiencies, in terms of we're scanning the world constantly. We're constantly looking at things, and there's certainly a wealth of data, right? A lot of data, but the insights, we're sending a ton of data down, and then we're processing kind of everything we collect. And there's some, questions in there, like why do we keep all the data we collect? Do we need to do that? And what are the implications of doing that? And then how are you starting to kind of approach doing that differently?
Certainly. Yes, you're correct. I think the current model for Earth observation, for the most part, involves, multiple constellations of satellites with different image sensors. And these satellites send vast amounts of raw data down to Earth. And at that point, the data is analyzed and insights and intelligence is generated. Now, the benefit of sending vast amounts of raw data for archiving on Earth is certainly a historical record, right? You can see how things have changed over time, and there's value there. There's value in developing a chain of custody over time. But the rub is that comes at an extremely high cost. When you transmit all of that raw data down to Earth, which has to be stored and curated, and only a small fraction of it is used, that results in a very fragile economic case, because ultimately the only people who could, in majority, can afford this are large enterprises and governments. And so while this model has its benefits, it's extremely constraining in terms of sort of the democratization of use of this extremely valuable resource. And so, what NOVI found was that a very vast subset of users actually only want the intelligence and insights that the data points to. They don't need to be overwhelmed with all this, raw data. And so if we can process at the space edge and send down bits and bytes of intelligence and insights, you completely change the economic equation. And this really liberates the market and use cases that can now be beneficiaries of Earth observation data.
Yeah, I mean, I think you hit it on the head there. Is that I've heard a lot of different ways this kind of argument about the wealth of data we have is kind of approached, right? You are kind of pulling everything and then you're maybe using a percentage of that. And especially with Earth observation, you're looking at maybe I just need a few bands of the data, not all of that. You're limited in your geographic scope. And we've created a lot of systems kind of just to navigate and find all through the files. But at the end of the day, what anyone cares about is like you said, that insight that comes out of it from that perspective. And it's been kind of an interesting case. I've seen like these, arguments for just keeping everything evolve and then go from there. So first of all, how did you guys realize this problem? Right? How did you like pinpoint who where this was coming from? I mean, and what did that look like? And I think what kind of led you to say we're really set up to do something like this, and kind of how did that start to evolve? Because I think your approaches and kind of the way you're approaching the problem is really unique. And we'll after you ask that, I want to start to unpack the term edge a little bit and talk about that. But first of all, like, okay, what were those use cases? Where did you find these? And then how did you say, okay, we're in the right position to solve these things?
Right. So I think there's a historical element, historical element involved in how we came and developed our current strategy and our current thoughts around Earth observation. As I mentioned, NOVI was founded in 2017, and we've been entirely working for the Department of Defense on national security projects. And in fact, we do have assets in space today that are a part of these missions and programs. So the company itself has space heritage. We've built the satellites, we've put in the edge compute, and we've managed launch and mission. The problem we were solving for national security was latency. One of getting time down, right? In national security, being able to detect some change and then report it in a minimum amount of time is extremely important. And that was really the technology we were working on for the defense industry, which required putting computer onto the satellite. Because, today's workflow is satellite sees something, sends it to a base station, goes to an air-conditioned room, it's analyzed, and then it's sent to an asset. Well, if that inference algorithms can see change and then just send down little bursts of information, lat-long coordinates, perimeter coordinates, and you can do this on channels like Inmarsat or Iridium, you can take a latency from days and hours to minutes and seconds, which matters in certain applications. So as we were solving this problem and working on this problem for the Department of Defense, we recognized that when you send down bits and bytes of information versus gigabytes of information, you're actually reducing cost very, very significantly, not by 10 or 20%, but by an order of magnitude or more. And this really sponsored us to think deeply about the Earth observation market. We recognize, like as in any industry, mobile phones, computers, whatever the case is, solar panels, if you can drive down cost, you drive down market adoption. So we thought about commercial market and recognized that we had the technology that we developed for national security that could drive down cost. But we also recognized that this was not the only impediment for Earth observation. You've got lots of satellites with different sensors, but they're non-coincidental. That results in, cumbersome fusion on the ground. You have none of these platforms are open access. They're highly curated and controlled and constraining. And probably one of the biggest things that we didn't initially realize, but a significant impediment in this industry is data rights. There are very, very constrained data rights from the operators to users to resellers, the the whole user base. And we recognized that that needed to change. So when we had broken the back of the cost problem, we then set about a strategy that addresses the other three challenges: a multi-sensor constellation that enables simple data richness, an open access platform that users can upload software onto, and very liberal data rights to really precipitate the trade of Earth observation data and the monetization of Earth observation data. So that was our evolution from defense into deciding to launch our own dual-use constellation, which will be used for both national security and civilian applications, and that goes up in about 6 months.
Well, I think where I find a lot of interest here is unpacking the question of edge computing, which is certainly a term that gets thrown around a lot, both in the form of terrestrial Earth edge computing, on our planet, and then now how do we apply that to satellites orbiting our Earth and understanding our planet? Because I mean, logically it makes sense, right? If you can just pull the insight from the device and send that down, right? From a computing perspective, that makes a ton of sense. And within that, there's all these economic benefits, which we'll dive into, market adoption, all these different things. But just help me kind of understand, okay, what does edge computing look like in the context of a constellation or satellites? And why is it kind of now coming to the forefront?
I think there's a few things to unwrap there. So, I mean, edge computing itself is co-locating the compute with the sensors. So you do the compute right at the sensors, and that's what really results in sort of the economic and latency benefits that we have discussed. But I think a lot of it is this is sort of the right time because there's a convergence, right? You have very fast compute in very small form factors requiring, low levels of power. You've got advanced sensors that are now packaged and tried and tested in space. You've got the ability to make these very low cost, powerful satellites, and courtesy of SpaceX, you can launch them at a pretty de minimis cost. So I think it's this convergence of economics and technology and miniaturization. We've arrived at that junction where you now have the viability to push processing to the edge in a manner that is very meaningful to things like economics and other factors.
Yeah. And it's funny because I think a lot of times there's when you have a big shift in an industry, you pointed this out to me, which I hadn't drawn this parallel before, but it's when you make things smaller, right? If you think of the iPhone, if you think of distributed computing, instead of just throwing big machines at a problem, throw a bunch of tiny machines and split the problem up. Even to how Google revolutionized search indexes by splitting them up and making them smaller, right? The more you can kind of shrink the problem in a way, that becomes important. So is this one of those moments? Are we at a moment where we can kind of apply the same strategic thinking of making technology or making the problem smaller?
So I think I like the analogy you use, right? The iPhone or smartphones. It was interesting. If you look at a smartphone, where is my smartphone? So a smartphone is nothing more than a sensor suite with onboard compute. And that's really what happened in 2007, right? When Apple launched the iPhone and then you had Android, you took feature phones, you put onboard compute on a sensor suite, you set up app stores, and in 2007, we couldn't even contemplate the types of apps we have today that this onboard compute on a sensor suite, a terrestrial sensor suite, has enabled. So we think we're at that same junction now in Earth observation because a satellite is basically a box with a bunch of sensors, and now you take sort of this feature satellite and make it a smart satellite, and then you open the platform to users. I couldn't even begin to posit what kind of applications we're going to have in 2 years and 3 years. But I think it's going to promote an explosion of Earth observation because if you drive the cost down, you've got a cheap platform that you open up to users. I think we're going to see use cases that are fairly staggering and creative.
Yeah. So I'm going in, if I'm a Earth observation kind of practitioner today, I have to, maybe I'm going to an open data portal. I'm getting stuff from Sentinel or Landsat, or maybe I'm going to a commercial kind of provider and looking at the images they have available. What's it going to look like in the future when I say, hey, I need to go to NOVI and kind of start to interact with the things you're sending down? What does that kind of world look like to me?
Certainly. So the first thing to define is sort of the hierarchy of data. So just consider Novi's constellation, right? Open access platform with a bunch of sensors. Those sensors and onboard compute, if a user wants raw data, as is done today, they can get raw data. They just pay for it. They can get clip data. So if you don't want a 200 kilometer square swath, but just want to look at 2 square kilometers, you pay for that. It's clipped in space and you pay less. And then, of course, there's the insights and intelligence. So there's sort of the hierarchy of data. So the users can get it all. So how it would really look like is there's think of 3 constituencies. Think of enterprises and government. So those users will have a workspace. And within that workspace, they're given the software development kit and given all the tools to upload software and generate insights. And certainly, we can provide a certain structural framework that is API friendly and provide all the tools for these enterprises and governments to task and use the satellite as they see fit. Then, when you get to smaller users, it'll be a very similar type of situation. Each users will have their little cubicle. They get an SDK, and then they can upload data and they can get the insights. We will also have a marketplace where users can just, if they want raw or clipped data, they basically point and click, and at the next pass, they get that data, or they can get certain insights. We will have some indigenous applications, just like in the App Store, Apple has some certain amount of applications and the rest is user developed. It'll be very similar with Novi. So that sort of gives you the enterprise and small user constellation. Then there's a developer space. Developers will be given a sandbox, an SDK. They'll have the ability to upload software applications and then sell them to users on a marketplace. And there's slightly different economics. For our enterprise users, we kind of work a little bit like AWS EC2 pricing, right? There's either long-term customers, there's burst customers, there's on-demand pricing, and then you have the whole developer user ecosystem that's wrapped up in an application marketplace.
Yeah. I mean, I think it's interesting because now I can just go straight to insight, and I see the applications and the platforms that are driving value in the space are really driving down to insight and things like that. I think there's also kind of in a similar way, and I think there's kind of another trend that's also taking place of like a big amount of data that's really focusing in on like foundational models, these big picture things and stuff like that. And then also driving the need of just massive amounts of data to drive AI workflows and stuff like that. How do you kind of compare those two trends of one of, precision insights, up to date, all those different things that we've been talking about so far. And the same side, there's collect as much data as possible, create these massive models, understand these types of things. How do they kind of play off of each other, interact? What's your take on those things?
I think there's sort of 2 overlapping swim lanes, right? So if you look at what Novi is doing, we're really focused on insight and insight and task generation in a low latency manner. So we're not really in the business of generating massive amounts of data to train foundational models. Now, certainly the data we generate, the insights that are generated can feed those models and can add value to the models. But we're fundamentally doing 2 different things. Instead of trying to develop massive amounts of data for these foundational models, we're providing users with the insights and information they require for specific tasks and specific use cases. But there's again the overlap, right? That once that information is generated, it can be leveraged and utilized for the development of these much larger data hungry models.
Yeah. And I think there's this kind of convergence, but we're still on very big ends of the spectrum of, big models that can kind of, I feel like people are trying to drive to the chat GPT moment of our industry, where I think we're just really far from that. We can tell similarity. We can start to see some things, right? But on the other moment, there's, I think, a need down here where I care about something specific right now. And exactly. I want to drive to those insights. And that's, I think, a big, kind of gap that we need to drive into and go from there. For those folks that care about, precision, timeliness, insight, focus. Can you tell me a little bit about some of like the industries or verticals that can really benefit from those types of things, that you're producing?
Certainly. So let's take a look at sort of the two two levers, right? There's cost and there's latency. So you can imagine in DoD type applications, the warfighter being able to look at the dynamic battlefield and get information near real time. That has a lot of tactical value from a national security and a warfighter perspective. You've got this persistent layer in space that's constantly informing and advising around dynamic change, so that resources can make faster, more informed decisions. And that's really around latency. And you can see the implications on even use cases like warfighter programs, Golden Dome, missile defense. That's those use cases are quite tangible, especially when it comes to latency. From a civilian use space standpoint, you have some applications verticals that require low latency, right? Wildfires, emergency and disaster response. So a lot of those arenas benefit from this low latency feature. But forestry departments, a lot of these folks also need it to be low cost, right? Low latency is a requirement. Low cost means more people can use it in nations around the world. So the cost now starts to really impact areas like precision agriculture, mining, maritime, forestry, environmental change, oil and gas, because the lower the cost, more constituents can use this tool and use it to address things like food security, more efficient mineral exploration, maritime monitoring to look out for dark fleets. So you can touch on a whole bunch of different things, hedge funds, logistics. But again, for this to be a useful tool, you have to drive the cost down for those users. Now, when the cost gets down significantly, we've even had conversations with people who talk about the gamification of space data. So you go from things like food security and defense to now you can imagine applications like the gamification of space data and maybe more micro-type solutions that smaller businesses can afford and smaller regional businesses. So really, those are the types of verticals and how we see latency and cost enabling them. And maybe, Matt, I can just give a very simple example, just to maybe provide a use case or some reference for the cost reduction. Imagine a hedge fund or a logistics firm wants to count ships in Baltimore Harbor every day for a year. That's really just 365 data points. Today, to source that raw data, have an analytics firm kick out those numbers, you're probably looking at a price tag of somewhere between $120,000 to $150,000 for the year. With Novi's solution, you can do that for under $1,000. So that's what I mean. It's not like you're going from 150 to 90,000. You're going from 150 to 1,000. And so that's sort of the profound value proposition that edge processing and sort of our approach to space will have.
And you're not just talking about the raw imagery, right? I mean, of course, that's something you could get, but you're actually saying, I'll tell you these things, where these ships are, day over day at whatever kind of frequency that you kind of want to go from, and give you just that raw insight. And I feel like that's exactly. A lot of the times when we talk about the big picture of Earth observation and what it can be, it's driving everything from how is land changing to where are buildings being built to how are our waterways being impacted, to counting individual things and understanding even down to like, is there an air conditioning unit on top of this building, right? That requires a very precise image to do that. And I think that's a lot of the things like our sensors can do that now. We're getting this really granular data it's amazing to see. But to, like you said, to buy that in bulk and then to do that and then to run the model, there's a tremendous amount of effort to do all of that. And I think that's the cool part, is to say now you just get the data back and the insight that you need, that's what I kind of love about this whole, there's two parts I love about this whole concept, is the inside out, of the system. But then also I think there's this interesting component of the processing, where the processing happens. And I think one big thing I've started to hear, right now we're processing all this down here on the planet, right? And you said these big data centers that have cooling and energy that need to run them and all these different things. I'm curious about the kind of, if I'm processing and I can do this on the device, what is the potential impact to, the need to process less data or process it more efficiently in these data systems on Earth? Because I think I've heard this a lot as AI just generally has boomed, is the demand for energy, the demand for compute, the demand for GPUs. I think there's another big impact that this could make is terms of just, okay, we can do this more efficiently using just compute that's already there, sitting on something floating around our space. So what does that dynamic look like on top of all the other things we've talked about, from
Right.
cost and speed and all of that?
Yeah, since you and I last talked, I did give it some thought, and I think at Novi, what we recognize is that the sort of the environmental footprint is not something we put forth, because if you look at our model, ultimately we do the processing in space, but the models still have to be trained on ground.
Yeah.
So you still need to have a lot of processing power on Earth, and then of course when we send the insights down, they have to be stored on ground. So I think we could certainly, doing some of the processing in space, we have an incremental impact, but it's probably not the type of impact that people talk about when they envision actually huge server farms in space and servers in space. So I think a lot of at least what I've seen about the, sort of the environmental impact is where people are talking about literally putting servers in space, powered by solar power, and really keeping all of the processing and storage in orbit. In our case, we're generating the insights, but the inference models are still trained on Earth, and then we bang the insights back off to Earth. So I think we have an incremental effect, but probably that's a second order effect in our solution and what we're offering.
Yeah, and I think that, of course, the training cost. I mean, when you look at any model, there's going to be your training time, energy cost, and then the production cost to run that. And I think that's another factor that even if depending on the size and the scope of the space you want to run this on, that model running cost can still be quite significant. To run that over. The training cost is kind of a sunk cost no matter what. The good news is I think there's so much research in the space, and there's so many good models being developed and things like that. So that's the exciting part. But I think as you kind of shift, I'm curious to see how that evolves, is terms of, okay, we have this thing, we can, we have these constellations, they have compute there, we can, I think where the coolest part is you can ship models up to space and then leverage that there with this whole SDK you're developing and saying, hey, now the model lives there, I get small insight back, and I can go from there, which is really cool. So it's an interesting thing. I'm curious just to see how that plays out over time as well, because I know that's, a lot of folks in our space are doing environmental work, and they're kind of like, well, I'm shifting all this compute and running things from that perspective, which is interesting.
I think you're quite right there. I mean, ultimately, I think there could be once the whole ecosystem moves up there, right? We're a small piece of it. We're doing the compute, but you can imagine once, if there is an abundance of servers actually residing in space, and you start to see the whole ecosystem truly move to the space edge, you could imagine that there could be some profound benefits there, but only as a part of the whole.
Yeah, it's a cool time, because I mean it's a little bit of an unknown, but I think as we point, like, as we've had this discussion, getting smaller is going to be a market shift, in terms of space and compute, direct access to insight, which is going to be key. And then I think the last one is kind of like the end benefit beyond just the insight the user is going to be kind of the market dynamics. And that simple example you gave in Baltimore Harbor kind of laid it out very clearly. I've seen this shift in, I think, geospatial is kind of driving to a more commoditized market where, instead of where it's these big kind of, you're buying these massive data sets and you have to do all these different things. I think access equates to, making it more accessible, which of course plays out in the market dynamics. And I think I'm curious to hear your approach. Like, how has that feedback been? Is that something people are like really kind of jumping on? Is that the approach that people want to take? They want to get access to that at cost. I'm assuming they do, when you lay it out from that perspective. But I've seen this across, not just in Earth observation, but across kind of a lot of things happening in geospatial and geospatial products. How have you seen that kind of take hold with the folks you're talking to?
Yeah, I think it's the short answer is we've seen a very strong reception, right? And it was interesting to me. The cost is an enabler. Without low cost, you simply can't open up the access. But one of the things that we didn't fully appreciate was how constraining today's data right models are. It's even if people, consumers or users, could get the data at a lower cost, but they're restricted in monetizing it or using it or trading in it, it serves the same serves it's the same barrier. You either have a cost barrier or an ownership data rights barrier. And I think one of the things that we have seen is we've seen, of course, a very strong reception to, if you can reduce costs down the way we can, there's a lot of enthusiasm around that. But having a platform where users have ownership rights over the data they generate and to then engage in the free trade of that data, I didn't realize the extent of how profoundly enthusiastic of a reception we're getting for that. And to me, it just points to the fact that today's operators have just firewalled their platforms. They've firewalled access. They've got all of these data rights because in a costly model, it's a fragile economic model. So they're trying to defend an incumbent legacy model that in and of itself is having a hard time closing the economic case outside of sort of the DoD realm. So something's got to break, something's got to change. And we believe those two elements are what we've seen a tremendous reception for: cost and data rights.
Yeah. And I think I'm glad you brought that up, because we talked about it briefly, but I like just acknowledge it again, is that what you can then do with the data that you get, right?
Right.
Where can you take it? How can you access that? That's also a unique value proposition that you're bringing forward, is the data rights, right? And there's certainly, that's something can be a very tricky area to navigate, be it open data, private data, whatever that is. But I think that was also something I like the technology compute stuff, but the data rights and access matter a ton. So I wanted to just call that out quickly, because that's another key component here is, okay, how are you letting people take this forward into what they're doing?
Yeah, and I think you bring up a good point there, and it fundamentally comes down to what you brought up in the beginning. We're not generating vast amounts of data and then constantly trying to remonetize a small portion of it, reselling it and trying to figure out how to slice, dice, and put licensing agreements and ownership rights. We're allowing people to task the satellite to do what they want it to do, and then they own the data they generate. They have ownership of the data they generate. So we're not trying to constantly peddle and repeddle vast amounts of data we generate without user input. Users are specifically tasking our satellites. They have the data, and then we hope they go and make a lot of money and have a lot of benefit from it.
That's cool. Yeah. It's basically the value proposition of a lot of things that have been transcendental shifts of cloud computing, consumer computing, all these different things. So it's cool to see that same model being applied now to Earth observation and stuff like that. So you mentioned 6 months, things are going live. Talk to me a little bit about the timeline from when we're recording this until what people can kind of expect from NOVI.
Yeah, so right now we're heads down building the spacecraft. So we have 2 spacecraft, the first 2 of our constellation going up. We're already manifest on transporters 16 and 17. And these will be multi-sensor satellites. So they will have RGB, they will have hyperspectral, possibly have RF. And then we will, after those first 2, that's really what we're laser focused on right now. The satellites are being built as we speak, and knock on wood, we're meeting all timelines and schedules. So that's going well. And then, but we won't be able to really rest after that launch because we're proliferating. We've got more satellites lined up, and we've got a proliferation strategy that is year in and year out, starting to develop enough critical mass in the constellation to give you true persistence.
Awesome. That's very cool. And then, where can people find out more? Where can they kind of start to learn about it and kind of follow along as as things start to become a reality here?
Certainly, on our website is probably the perfect place to go. Clearly, we've got LinkedIn. LinkedIn also as a resource where we put a lot of our new announcements and our progress and customers we're working with. So, but I would say as a starting point, our homepage at www.novispace.ai.
Yeah, and I'll make sure to include everything kind of in the show notes here. So depending on if you're watching this or listening, whatever platform you're on, find the description. We'll put all the relevant links and everything into the recording here. Yeah, Michael, anything else we didn't cover or you wanted to touch on today?
No, I think I think maybe just one point, which is always interesting to me, and a question I get frequently is, what use cases? Who are the verticals? And of course, we talked about the verticals, right? Agriculture, mining. It's the same cast of characters that are always referenced. And the question I get is, well, what would be the new use cases? And my idea is, I have no bloody idea. I don't think people in 2007 knew what kind of use cases were going to happen with the App Store. So I don't know necessarily what the use cases are. I just know that if as not just Novi, but we the industry transition into this low cost, liberal platform use in space, I think we're going to see an amazing proliferation of use cases, and it's a very exciting time to be in the space industry.
Well, that's the fun part. Is I always have fun going on some of like the GitHub repos, looking at the models that can be run, and and
Right.
and to kind of put a bow on it. At one point, I found a model that can detect elephants, and track elephant
Yeah.
herds and see how those are moving and migrating and evolving. Of course, what do you need for that? High resolution data consistently that can do that. And I just think that the big, we don't know what's going to happen, but when you lower the cost to entry and bring access forward, cool things can happen. And I think that's kind of what you guys are doing there, and I'm excited to kind of see everything get rolling here. And yeah, we'll have to chat after things kind of really get up in space, and then we see people starting to bring some of these cool use cases forward.
Yeah, no, it's been a delight talking to you. I really appreciate you taking the time to have this discussion with me, and I look forward to talking to you soon.
Sounds good. Well, Michael, thank you again. I'll leave everything in the show notes so you can check those out. And yeah, we'll talk soon.
Have a wonderful day. Take care.
Take care.